Hello students, welcome. Previously from 4 to 2, lesson 12, we were dealing Hess's law using the flip, or we were calculating Hess's law using the flip formula, and we have done example 2. So today, lesson 13, we are going to do example 3. So we are told use the standard enthalpies of combustion below to calculate the enthalpy of formation of propane. So how do you write propane? Propane is written C3H8. So what are the elements that form propane? Those are carbon, which is solid, plus hydrogen gas. So we are going to get, or we are going to form propane, which is also a gas. Okay, this is our demand question, because we said for you to do Hess's law using the flip formula, you are supposed to have your demand question. So this is the demand question. Okay, so check, we have not balanced the question. We have to balance. We are having 3 carbon on the product side, so we have to put 3 on the reactant side. We have 8 hydrogen on the product side, so we have to put 2, so that we have 8 atoms of oxygen on the reactant side. I mean hydrogen on the reactant side. So next, let's go to the thermochemical equations given. Here, the demand question, we are given 3 mole of carbon, which is solid. And in the thermochemical equations given, I have carbon reacting with oxygen, giving us carbon dioxide. So this is 1 mole of carbon. So what we are supposed to do is, we are supposed to multiply the whole equation, including even the enthalpy change for the formation or for the combustion of carbon, by 3. So let's just remove the bracket. We are going to get 3 of carbon plus 3 mole of oxygen gas. Arrow, we are going to get 3 mole of carbon dioxide gas. Then if we take even the enthalpy change itself, then we multiply times 3, we are going to get negative 1179 kilojoules per mole. Okay, next, on the demand side, the demand question, we have 4 moles of hydrogen gas. And here the thermochemical equation given on the combustion of hydrogen, we have only 1 mole. So we take the whole equation, we put times 4. To remove, we are going to have 4 moles of hydrogen gas plus 2 mole of oxygen gas. Because there we have 4 multiplied by a half. So half of oxygen. So by 2, 1, by 2, 2. So we are going to get 2 mole of oxygen gas. Then we have arrow. Then we are going to have there 4 mole of water, which is liquid. So to multiply this enthalpy for the combustion of hydrogen by 4, we are going to get negative 1144 kilojoules per mole. Then the last side, we are having here propane. This propane is on the product side, but the thermochemical equation given, we have combustion of propane, but the propane is given is on the reactant side. So we are supposed to flip this equation, or we are going to reverse. So to reverse, that means you are supposed to take your product and make it as your reactant. So we are having 3 mole of carbon dioxide gas plus 4 moles of water, which is liquid, then arrow, then that means your initial reactants will become now your product. So we have propane, which is a gas, plus 5 moles of oxygen gas. So the enthalpy change, I mean the heat change for the combustion of propane will be also reversed. It will going to be reversed. So if it is negative, we are going to make it positive. Okay, kilojoules. The next, what we are going to do is, we are going to just eliminate the substance that are found on the reactant side. If they are found or seen on the product side, we are going to cancel out, or we are going to eliminate. So here we have let's start with the 3 mole of carbon dioxide here on the reactant side, and here we have 3 moles of carbon dioxide on the product side. So that 3 moles will go with 3. So what you're supposed to say is only 3 of carbon dioxide minus 3 of carbon dioxide. This will give you 0 of carbon dioxide. So next, we are having here on the reactant side 4 moles of water. But on the product side here, we also have 4 moles of water. So that means 4 moles of water will go with 4 moles of water. It is just you saying 4 moles of water minus 4 moles of water. So here you're going to get 0 moles of water, or 0 water. There's no water there. So next, we are supposed to count again the number of oxygen that we are going to have on the reactant side. Here I have 3 of oxygen gas, 3 moles of oxygen gas, and here I have 2 moles of oxygen gas, giving me a total of 5 moles of oxygen gas. But on the product side, I have here, which I have 5 moles of oxygen gas. So that means the 5 moles of oxygen, 5 moles of oxygen gas on the reactant side will go with the 5 moles of oxygen gas on the product side. So there we are going to have no oxygen gas. So the overall equation here, we are going to have 3 moles of carbon, which is here, plus we have 4 moles of hydrogen gas, which is here. Then we have only propane, which is also a gas on our product side. The rest has been cancelled out. Okay, in doing so, you are supposed to add your heat change after doing the flipping formula. That means we are supposed to add negative 1179 kilojoules per mole plus negative 1144 kilojoules per mole plus 2209 kilojoules per mole, giving me a total of negative 114 kilojoules per mole. So this negative 114 kilojoules per mole will be the enthalpy of the formation of propane, which we are asked to find out. Okay, that's the end of our lesson.